Hi everyone. We are moving on with circuits, and now we're going to go into some circuits that are non-traditionally drawn. Okay, so this is 4.5 using all three rules together, level 3. Again, if you're in Physics 131, this is homework 7 on circuits. If you're in Physics 112, this is just the homework called circuits. And again, keep reading Coletta, chapter 18-2, chapter 19, and chapter 20. The rules that we're going to go through, haven't changed. So Ohm's law is V equals IR. I is equal V over R, and R is equal V over I. The Kirchhoff's junction rule, we've been working with that. The amount of current going into a junction is the amount of current going out of a junction. The consequence of that is that if you have two resistors or two components that are in series with each other, and you know one current on one guy, then that will be the current on the other. And you could also group up resistors, and they will act like one resistor. So if you have two resistors that are in series, you could add them together, and that will be just kind of like one resistor. Okay. The third rule, Kirchhoff's, and that should be 2 H's. I'm going to edit that right now. Oops, not a capital H. Just put a single H right there. Save that. And going to have to extend that. And save that again. All right. Kirchhoff's loop rule is this. Within one loop, the battery produces voltage and the resistors consume that voltage, right? So the consequence of that is that if you know the voltage on across one parallel branch, that'll be the voltage across the other parallel branch. Okay, and I am referring to the branches. If you have two resistors that are in parallel with each other, take the product of those two resistors and divide it by the sum of those two resistors, and then you will have then that will merge those two resistors in together into one equivalent resistor. And so they'll behave just like one equivalent resistor having the product over sum of those two resistances. Right? So moving on to these puzzles. These puzzles will hinge upon, and here we have another area where it needs another H. And while I'm here, I'll just do the other one. Sorry about the misspellings of those. These puzzles will hinge upon you plotting out the currents across each loop, into a junction and then out of a junction, okay? And you'll notice the inputs for those, for each resistor and the battery. You're going to have to put those inputs down here rather than attached to each one of the resistors up here. So let's get started. Why don't you go ahead and take a crack at this one and plot the currents coming out of the battery and then splitting off into the junctions and going through all the resistors and then coming back into the battery. And then try to go ahead and figure out the voltage, current, and resistance of each one of the objects. Okay, good luck. And pause the video now. Okay, let's go ahead and try it. So I'm going to go ahead to markup document. So by hitting the comment, then I'm going to put this arrow back. Right, so let's go ahead and start drawing some arrows. All right, this first one I'm going to draw, I'm going to use red to draw it. Okay, so this battery is producing a current, and that same current is going back into the system. Okay. And that current, I believe they say it is 4 amps. 4 amps. Okay. And that means 4 amps is going in. So the battery is a 36 volt battery. It's producing 4 amps. Okay. And that 4 amps is leaving. Okay. And they're saying that that 4 amps is going across A, and that other 4 amps has to be, that 4 amps has to be going across F as well, right? It's only got one path to go. Okay. So that means A is getting 4 amps, and that means F is getting 4 amps. Okay. Now that 4 amps is coming into this junction. It's going to split up, and it might split up in, it'll definitely be a different current, but I don't know what it's going to split up to. So I'm going to use blue for the current that's going to the right. Okay. Blue for the current that's going to the right. And then I'm going to use green for the current that is heading down. I'm going to use green for the current that's heading down. Okay? So red is going in, blue is going to the right, green is heading down. That blue current is going to head across. It's going to head across R3. It's going to head across the D resistor. And then it's going to head across, it's going to go across E, and it's going to head back in to this lower junction and then join up with green to become red again, to become the red 4 amps. Okay? So at first looking at this, you may think, well, this battery is in parallel with C, and that is in parallel with D. And that's not accurate, okay? This entire thing is not a traditionally drawn circuit. So you could take the time to redraw it, but I like just tracing the current, right? So what we're going to do is just follow the current and follow what the current is doing. So 4 amps is leaving, 4 amps is heading to the right across A. It hits a junction, and now we have to apply Rule 2, and that current is going to split up in 2 different currents and then flow back into here. Now there's a clue here if we're following the current that it says right here E is getting 1 amp. Well, this blue current is coming across B, and then all of it is coming across D, and all of it is coming across E. Okay, and since that's the same current, then the current, all the current going across E is the same current going across B and D. So now we know the current going across B and D, which has to be 1 amp as well. And even though it's right there below, I'm going to put it right here so I could see that the 4 amps is leaving, and the blue 1 amp is coming in. So this kind of helps us a little bit, because now we know we could, using that green is coming in, joining up with blue being 1 amp, and that 4 amps is leaving. Well, if 4 amps is leaving, so what that means is red is equal to green plus blue. Well, red is 4 amps, blue is 1 amp, and what that means is that green has to be 3 amps. Because 3 amps plus 1 amp is equal to 4 amps. Okay? And so now I've been able to functionally trace all of the currents. Okay? So now we can start computing voltages. So let's do it. So what I can see here is that this red, the battery is actually in parallel with A and this is a sub branch, and then also with F. So this is actually one entire branch. And what I'm going to do is I'm just going to quickly draw what I can sketch of what I think it's going to look like. Okay, so I'm grabbing my tablet right now. I'm setting it up. I'm grabbing my little pen. And I'm going to draw what I think this looks like. Okay, so if I'm going to have to draw this really small. Okay, so what I'm thinking is that the battery looks like this, and it's coming out. Current is coming out here. And what you have is you have a sub-parallel branch which is leading back into that. Okay. And A is right here, C is right here, and then you have B, D, and E right there. And B, D, and E are all in parallel with C. And then what we have is F left over. So this is what, by tracing this current, is what seems to be happening. This is a sub-parallel branch, a part of a longer branch. Okay? So by doing this, let's go ahead and start making some computations. All right? Well, since we know the current and resistance of F, we know that F is going to be 4 amps times 4 ohms. That's got to be 16 volts. All right. Let me stretch that so you can actually see the volt, the unit there. Okay. And over here, I'm going to try to start filling in the blanks. Everywhere I see that I have 2 variables, I'm going to apply Ohm's law. C is 4 ohms and 3 amps. So that's got to be 12. 4 times 3 is 12. B is 1 amp and 7 ohms. So that is going to be just 7 volts. D is 3 ohms and 1 amp, which is 3 volts. And we don't know what this is, but we'll be able to figure it out. Okay. Well, from what we could see when we redrew it, C is down here. And as you can see, whenever you have a junction and the current splits, that means whatever is getting one current is in parallel with whatever is getting the other current. That means this. C is in parallel with B, D, and E. And B, D, and E are in series with each other, right? That's why they get the same current. So if this is 12 volts, this, then that means that B plus D, B's voltage plus D's voltage plus E's voltage has to be equal to C's voltage, because that means they're in parallel. The voltage here is equal to the voltage across all of this, and that's the loop rule. So 7 plus 3 is going to be 10, and what that means is that, whoops, Control Z, and that E has to be 2. Because 7 plus 3 plus 2 is equal to 12, and that's in parallel with this. Okay? And I'll fill in this in a second. I need to find the voltage here, and we know the voltage here. So 36 volts is leaving. 36 volts is what the battery's producing. And I'm going to follow this loop now. This loop is 12 volts plus 16 volts, which is going to be 28 volts, right? And the total needs to be 36, right? Because this battery is in parallel with A, C, and A, C, and F. So the voltage at C plus the voltage at F plus the voltage at A has to be equal to what is being produced by the battery. Okay? So 12 volts plus 16 volts, 28. And what that says to me is that this has to be what is left over. Okay, what is happening here? So this is, so 36 minus 28, what is that? That is 8 volts, right? And again, if you make a mistake in here, if you get a fraction on anything, then you've made a mistake. So 8 volts divided by 4 ohms, that should be, that's going to be 8 ohms. And forget that. A W is an ohm. That's a symbol. Cool. Well, it looks like we got everything. Let's go ahead and fill in all the blanks. We've got all 3 variables on all resistors. I'm just checking that. Oops, didn't get the voltage here. The resistor there. 2 volts divided by 1 amp is going to be 2 ohms. So, cool. Got all 3 of those, got all 3 of these. Pretty neat. All right, so what I'm going to do is I'm going to input in all these values. So let's just look at A right now. Voltage at A is 8. The current is 4. And that should actually be 2, not 8. So I'm going to put in 2 here because 8 divided by 4 is not 8. Good Lord. B is 7 volts, 1 amp, and 7 ohms. C is going to be 3 volts, 1 amp. Well, actually, C is right here. I was looking at D. Sorry about that. C is going to be 12 volts, 3 amps, and 4 ohms is already filled in. D is going to be 3 volts, 1 amp, and 3 ohms is already filled in. E is going to be 2 volts, 2 ohms, and finally F is going to be 16 volts, 4 amps, and then 4 ohms. And there you go. That is this puzzle that was in Kirchhoff and Ohm's Law 3. Let's move in to another puzzle. Okay. Again, we have a Grumpy Kitty. Love Grumpy Kitties. Here we go. Let's try it. again, what I want you to do is you're going to track the current as it leaves the battery here, and then draw another arrow for the same current coming back in. So the current that leaves has to be the current that's coming in. Follow the current as it goes around each of the resistors, and when it hits a junction, it's going to split and change into different currents. Okay. So, and that lets you know what's in parallel with what. If the current splits, that means it's in parallel with whatever the other current is. Okay. So go ahead and follow those currents around and try to do your best to fill in these parts. Okay. Good luck. Hit pause, actually, and try this yourself. Okay. We're back. What I'm going to do is I'm going to grab some values here and just leave this so I have these little tools ready. And leave this to the side. All right. I'm going to start by following the current that is coming out from the battery. And that is going to be a red arrow. I'm going to bring this to the battery. That arrow is going to be small. And it's just going to, that first current is just that, it looks like it's going to be a 9 amp current. It's going to leave right here. It's going to leave the top of the current. And that same 9 amps is going to be coming in. Oops. That same 9 amps is going to be coming into the bottom. Okay. And what I'm going to do is I'm going to go up here and grab this guy. And try to use the same colors that I was using before. So we know that this is going to be 9 amps coming in. Okay. So 9 amps is leaving, 9 amps is coming in. Okay. Now the current is going to start splitting, and what it's looking like to me is that it's going to split into 1, 2, 3 distinct currents. So even though this junction isn't right here joined with this other two, I could see that this whole thing is a kind of a large junction. Red is going to come up, it's going to split. Part of the current is going to head over to the right, and then the rest of the current is going to go up here, and when it hits a section junction, you're going to have another current go to the right and another current go to the left. So what we're going to do is we're going to follow those. I'm going to draw a different current now, and I'm going to call this one, blue. All right, so blue is going to leave to the right. Blue is going to head through D and E. And then blue is going to head down and go back in here. All right. Well, let's try another color. That means, let's say here to the right, we're going to have a green current head to the right. And that means the green current is going to end up joining up with the blue current over here at the bottom, and then coming back into here. And that green current is going to head across the F, the little F guy here. Okay, and I'll just put that right here. Okay, let's try, so we have red coming in, blue leaving, green leaving, and then we're going to have a third current going to the right. I'm going to just grab, let's do pink. I like pink. I think I've said that before. Let's go ahead and we're going to make a pink arrow. Why is it coming out green? That's weird. It's not taking my direction. All right. So we got we have a pink arrow leaving. And what that means is this pink arrow is coming across this 15 volt resistor, joining up with blue and joining up with green, and going back in. So what we have, let's just track our colors here. And I'll just stop for a second here. So what it's looking like is we have red heading up out of the battery, splitting off into blue, which is then coming back in around. So that means that D and E are in parallel with the battery. Green is then heading up and to the right, heading down, going across, and then coming back in. And so that means green is also in parallel with the battery. So this is its own branch, and that is also in parallel with D. All right. And pink is heading up and heading to the left, splitting up through here, heading across here, heading through the wire, heading down through C, heading across and joining up with green and blue to form red again. Okay, so now that we've traced the currents, let's go ahead and try it. All right. Let's do something else too. Let's assign some colors to the split up of pink across this branch. So I grabbed an arrow. And I'm going to give one of those colors orange. So pink is going to head into this subparallel branch, and it's going to split up into orange, which is going to head into B, head across B, go up through that wire and join up with another color. What color should we give A? What color should A be? Let's give A kind of a baby blue color. All right. So baby blue, so A is going to join up with orange to form pink again. Okay. And I'll just grab a little pink current. It's leaving. All right. So now we've traced all the currents across everything. So pink is going to head into the subparallel branch. Orange is going to go across B. Baby blue is going to go across A and then join up with pink again to go all the way down through here and go through C. So now that we've traced our currents, let's go ahead and start figuring out some of the values here. Okay, let's start with blue and see how far we can get. So red is heading up, splitting off into blue, and so blue is going to come around, the current blue is going to go through D and then go through and go back in. So we know D and E is a parallel branch to our battery. So that means our battery is producing 9 volts. D and E, by loop law, the third rule, has to be consuming 9 volts. Well, 12 of those 9 volts is being consumed by D, and that means the rest of that 9 volts, the rest of that 21 volts has to be consumed by E, which is going to be 9 volts. Okay. All right, so that's pretty cool. That's about as far as we could get with this. Without a current, we can't figure out the rest. All right, let's go up to C. Let's go up to green. So red is going to go up. It's going to split off into blue current, and then pink is going to head to the left. Blue is going to head to the right, and here, and green is going to head to the right. And so green is then going to head down, and we have an indication of what green is. Green is 3 amps. And so what I'm going to do is label green. Now that we know green is 3 amps, we're going to call that 3 amps. It's going to head across F, head to the left, and then join up with blue and pink to form red again. All right. We also know that since this is green, it's in parallel with this branch right here. So red has split up into blue, green, and pink. And so what that means is F is in parallel with our battery. That means we know what the voltage of that is. That means we know F is 21 volts. Okay. And if that's 21 volts, 21 divided by 3 is going to be 7 ohms. So now we have all the components of F. Right? And we also know that out of the 9 amps that's leaving, 3 of the amps is going here. That means we have 6 amps left over. Okay? All right. Let's try something else. We've gone as far as we can with D and E, and we've completed the green, F. Let's head and do the pink branch. Now, all of this is in parallel with our battery, because again, red has split up into pink, which is then split up into a subparallel branch, then joined together to pink again, gone all the way across C and back into here. And that means since red is in parallel with all of this, and we know that this branch is 21 volts, we know that 15 of that 21 volts is here. That means the other 6 volts has to be going across here. So we know that this whole branch is consuming, this subparallel branch is consuming 6 volts. What that means is that B has got to be 6 volts, and that A is 6 volts, right? Well, now that we have 2 components, well, now we could start getting some currents. Okay, so 6 volts divided by 3 ohms is going to be 2 amps. And we're going to call that orange. So that means orange is going to be 2 amps. And that 6 volts divided by 6 ohms is going to be 1 amp. And so that is baby blue. That's pretty cool. Since we have that, now we know that pink has split up into 1 amp and 2 amps. And what that means is that pink is actually also 3 amps. But even though it's 3 amps and it's the same value as green, it is a different current. So we know that this is 3 amps, and that we know C is getting 3 amps, and that we know that pink up here is split off into 3 amps. While we're here, let's get the resistance. We know 15 volts divided by 3 amps is going to be 5 ohms. Okay. We have all the components for the pink branch now. Let's go back to the blue branch and try to get and find its current. Well, 9 amps is leaving. Blue is splitting off. Green 3 amps is splitting off to the right. Pink 3 amps is splitting off to the left. That means that's going to be 6 amps. And what that tells me is that blue has to also be 3 amps. Because 9 amps coming in, 3 amps plus 3 amps plus 3 amps has to be what's leaving. Okay? So that means D is 3 amps and E is 3 amps. Okay? Now that we have that, we could figure out the resistance. 12 volts divided by 3 amps is going to be 4 ohms. 9 volts divided by 3 amps is going to be 3 ohms. Okay. Cool. Let's go ahead and fill in our... So now that we have actually everything that we need, let's go ahead, and there's numbers everywhere. Let's go ahead and fill out this spreadsheet right here. So let's find A. Where is A at? C, D, E, F. A is up here. Wow, A is way up here. So A is going to be 6 volts, 6 ohms, and 1 amp. Okay. B is going to be 6 volts. It's going to be 2 amps, and it's 3 ohms. C is going to be 15 volts, 3 amps, 5 ohms. D, where's D? D is right here. D is going to be 12 volts, 3 amps, 4 ohms. E, right here, is going to be 9 volts, 3 amps, and 3 ohms. F is going to be 21 volts, 3 amps, 7 ohms. And that is all of the practice. So what I want you to do is I want you to practice following those currents around and do your best on this lab tutorial. All right, good luck.